we spoke before about how when you solve equations, the degree of the equation indicates the number of solutions. So like this guy right here, you should have 2 solutions. But in the last section we learned that those kinds of equations seem like they don't have any solution, right? But they actually just don't have any real solutions. So that means we need to start talking a little bit about other types of solutions that we can have. And those are the set of solutions that belong to the complex number system, or in other words, imaginary numbers. So the first thing that we do is we define imaginary numbers. The letter I is the imaginary number which is defined as the square root of -1. So let's talk a little bit about how we use I first, and then we'll get to the part where we solve equations. So how could you simplify the square root of -7? Well, we're going to use this property. The square root of A times B is equal to the square root of A times the square root of B. So this is going to become the square root of -1 times the square root of 7. And then this guy right here is going to become I. So this is going to be I root 7. So it's just like the way we simplified radicals before, but instead of pulling out a perfect square, we're going to pull out the square root of -1. So let's try example 2. Square root of -1 times the square root of 19. This guy, remember, is defined as I, and we get I root 19. On example 3, you notice that when we pull it apart, we get the square root of -1 and then the square root of 25. Both of these can be turned into something else. This guy, of course, is I, and this guy, of course, is 5, and the answer is 5I. Let's do it again for example 4. This time, some of the numbers will result in whole numbers. The square root of -1 will result in I, and some of the numbers will stay under the radical. Root -1 times root 4 times root 3. Of course, this is I, and this is 2. And the root 3 will stay under the radical. So this is a little bit about what it looks like when you simplify the square root of a negative number using imaginary numbers I. Let's use it to solve equations. So now let's look at number 5. We can't factor this, but of course we could use the quadratic formula. So let's do that. Right away we see that the radical is going to be negative. So we get x equals -6 plus or minus 36 minus 40 is going to be -4 all over 2. Now before we would have stopped and we wouldn't have been able to go any further. But now we know that the square root of -4 is going to be equal to 2i. -6 plus or minus 2i all over 2, and then we're going to simplify this radical. -6 over 2 is -3 plus or minus I, and that is my answer. Now technically this is 2 answers, so you can write it as x equals -3 plus or minus I, or you could split it, -3 plus I, -3 minus I. Alright, let's take a look at example number 4. Opposite of b, plus or minus b squared minus 4 times a times c all over 2a. So this is going to turn into three plus or minus the square root of -207 all over 9 We can pull a 9 out of this guy. So this is 3 plus or minus 3I root 23 all over 9. And then we're going to divide everything by 3. We're going to get 1/3 plus or minus, because we're going to do this, oops, this is not a 1/3. Let's go back for 1 second. There we go. We're going to do this. And we're going to get 1/3 plus or minus I root 23 all over 3. And because these aren't real numbers, we can't put them into decimal approximations, so we just leave it just like that. So complex numbers. So complex number actually has two parts. It has A, which is the real part, and then it has BI, which is the imaginary part. So a whole number like 5 can be a complex number. It's just 5 plus 0I. And then of course an imaginary number can be a complex number. It's just 0 real parts plus some imaginary part. So the rules for adding, subtracting, multiplying, and dividing complex numbers are fairly simple. In the rules for adding and subtracting, all you have to do is add and subtract like terms. So we kind of talked about this before, the putting similar things with each other, right? So if I'm going to add this guy, right, then I'm going to have to put the real part with the real part. That's here. And then I'm going to put the imaginary parts together. That's here. Right? Same rule for subtracting. You just subtract instead of add. For multiplication by a scalar, all you have to do is distribute. By the scalar. In other words, k times the real part, k times the imaginary part. And for multiplication, you need to know a little bit about the way I works, right? So this is just an application of the definition of I, right? I is the square root of -1. So of course, if you square I, you get -1. So let's take a look at a couple of these examples. All right, first off, let's do a problem with subtraction. I'm going to start with the scalar part. And then I'm going to combine like terms. Real with real. Imaginary with imaginary. 3 minus 20 is minus 17. 2i plus 4i is 6i. Okay, next one. All right, in example number 7, one really important part here, and that is that anytime you're multiplying two radicals together that both happen to be negative radicals, you have to pull the negative out first, okay? So you want to deal with the i's first. This is critical. If you forget to do that, then you're going to end up with the wrong sign at the end, okay? So I'm going to turn negative root 5 into I root 5. And I'm going to turn negative root 10 into I root 10. Now you can multiply them together. I times I is I squared. And then this is going to be root 50. Okay, well, I squared we know is equal to -1. And then root 50 can be broken down into 5 root 2. So this whole thing would be equal to minus 5 root 2. Okay, we're looking at example number 8 now. This is two binomials multiplied together, so of course we're going to FOIL. So 2 times 4 is 8. 2 times -2i is minus 4i. 3i times 4 is 12i. And then of course we have 3i times negative 2i, which is negative 6i squared. So we're going to want to combine like terms, and we're also going to want to turn this I squared into negative 1. So that's going to make this 8 plus, and then of course this is going to turn into positive 6, so that's 14. And then a minus 4i plus a 12i is a positive 8i, and that's my final answer. Now, one important thing that we do with I is sometimes we want to get rid of I terms, imaginary terms, especially if they're in the denominator. So one of the ways we do that is we multiply by the conjugate. So remember that when you FOIL out two conjugates together, you're going to do firsts. Outsides and insides are going to cancel each other, and then you're going to do lasts. So you really only have to do firsts and lasts. So 2 times 2 is 4. Then 3i times negative 3i is negative 9i squared. And again, remember that this guy right here is equal to negative 1, making this equal to 9. So what you end up with actually is 4 plus 9, and you end up with a real number, which is going to be 13. So for division of complex numbers, we don't actually divide, okay? There's no real way to divide. But we do a series of operations to make sure that we get an expression that allows us at least some kind of division, and that is we can't have any imaginary values in the denominator. So we're going to have to get the imaginary part out of the denominator, and the way we're going to do that is using the little technique which we just looked at, which is to multiply by the conjugate. So we'll multiply here by 1 plus 2i. Then, of course, if you're going to multiply the denominator by 1 plus 2i, you have to multiply the numerator by 1 plus 2i. Okay, so let's take a look at what this would be like. In the top, I'm going to FOIL this out. I'm going to get 6 plus 12i minus 7i minus 14i squared. In the denominator, I'm going to do a lot less work because all I have to do are first and last. So I'm going to get 1, and then I'm going to get minus 4i squared, or 1 plus 4. So simplifying the numerator, I'm going to get 6 plus 14, which is 20, plus 5i, all over 5. And then the last thing I want to do is just divide everything by 5 so it's simple. And I get 4 plus I. Let's take a look at example number 11. In the case of example number 11, the denominator doesn't have a binomial. It just has a monomial, right? So I don't need to multiply by a conjugate here. What I can do is I can just multiply the top and bottom by I. What's going to happen is the i's in the denominator are going to become I squared, and that's negative 1, and that's a real number, and that's all I really am going for. So the top is going to become 3i plus 2i squared. The bottom's going to become 4i squared. So now I'm going to turn all these I squareds into negative 1s. That's going to make this problem equal to 3i minus 2 on the top, and on the bottom it's going to turn into negative 4. So the last thing I want to do with this guy is I want to write him as a complex number. Remember, a complex number is of the form a plus bi, and that's going to be 1/2, that's the real part, and then minus 3/4 I. And that's my final answer.